Yay, we're live. Hello, everybody who's
Hey,
watching the behind the scenes video of our hack chat. So in all the social media networks, you'll see the hack chat link. This is Hackaday's chat. This is um, CircuitPython happenings. Lamore lead engineer is here. Scott lead of CircuitPython is here. Me, former founder of Hackaday, have nothing to do with Hackaday now other than helping out with the video and answering questions that I can answer as well. I think we're doing this for the next half an hour. Dan Mahoney is in the hack chat. Just posted up a link there. So the topic is CircuitPython happenings and more. I think the last hack chat we did was earlier in the year. So we'll see, maybe a year ago. So we'll see how.
yeah, it's January 2022. Wow, time flies.
Time flies. So lots happened. Scott, maybe you want to start off with like what's some of the latest releases and more.
Yeah, I was just looking back at CircuitPython stuff, and a personal note is that I was actually out a lot of last year as well because I had a kid, as did you two.
Yeah.
But I was looking back
collect them all.
Yeah, collect them all. But I think one of the kind of going back from what we're doing now and going back a little bit before that, I'm currently working on USB host support. So the idea that you can plug in a USB device into a CircuitPython device, and if it's keyboard, you'll get serial input, and if it's not, then your Python code can use it. That's one thing I'm working on. Jeff has recently done a lot of synth.io improvements, which is auto-generating or generating audio from like synthesizing audio from CircuitPython, which has been really cool. And Todd Bott and John Park deserve some credit there, giving Jeff the direction to go. And then some things that happened kind of like further ago was like web workflow, which is the ability to use and edit CircuitPython over Wi-Fi, which people have been picking up and really using. And then before that, we had BLE workflow as well. In terms of supporting chips, I think like 2022, like RP2040 was still around, but we had Scilabs come along and do the MG24s, which is pretty neat. So that's kind of the latest chipset that we've had supported, and it is really awesome to see Scilabs do that work to have it supported. So kudos to them.
And it's supported on a SparkFun board. We just got the word out, so if you're interested in that, we have it in our press section and more.
Yeah, I ordered them. So there's.
Yeah, I have one of those dev kits
board,
too.
And then this is the SparkFun board.
All right, someone said they missed your deep dive, which is what about that, Scott?
Labs. Oh, breaking news. And sorry, I have a bit of a cold. Hamzad says, haven't seen you in a while. Hope all is great. I missed your Friday deep dives. Well, I just talked with Tim yesterday, and I'm going to start doing deep dives again. Starting this week, we'll talk USB hosts. So that's 2 p.m. Pacific on the Adafruit channel. I'm only going to commit to doing an hour, but if we go 2 hours, it'll happen. But yeah, it depends a lot on childcare situation largely. So Foamy Guy will continue to stream Saturday mornings and some other random times, and then also fill in for me when I can't do Fridays. So that's happening, and I'm excited to get back into deep diving now that we've gotten to this daycare world.
You have done more, low level hardware. I think what's cool is we did DVI output on the RP2040. So
right.
The last year and a half, there haven't been as many new chipsets because everyone's kind of getting through this chip shortage mess of the last year or so, year and a half.
Mm-hmm.
Some parts are still not available, but in the meantime, we were like, well, if there's there's not new chipsets coming out, let's support some old ones. And so we've added a lot more stuff for RP2040. We've added a lot more for ESP. The ESP non-USB chips got added. So the classic ESP32, ESP32C3, which doesn't have native USB, only has USB serial. And there's going to be like the new H7, whatever chipsets that come out from ESP, and we'll support those as well. And then also the IMX RT series.
Yeah, a lot of work for the IMX RT. And it's been also, going back to the RP2040, it's been cool to see people really push the bounds of PIO for both the DVI output and the USB host, which we now have as well, based on PIO.
Yeah, I'm surprised that the PIO is from Sekong, I think, is the name of the developer who wrote like a demo, and I was like, wow, this actually works. And Tak, who works for Adafruit on TinyUSB, added it to TinyUSB so that both Arduino and CircuitPython can take advantage of like USB host, like, on a secondary set of pins. Because, like, a lot of chips have USB host built in, but like then you lose your main USB connection. And I always found that like a terrible development system.
Totally. Yeah. Yeah, especially because, USB is so core to CircuitPython, and it still is.
Yeah. Okay, so I don't know if there's any other questions.
Yeah, I was hitting the chat. They said, the new parent eye rubbing. I'm like, we actually have some CircuitPython powered kids toys. It's a very fun story.
Yeah, and we were going to use it as a test platform for the web workflow, but I have my board here. I just haven't actually put it in the toy.
Yeah, well, I'm waiting for you to get through some USB host stuff, and then I'm like, okay, now we can do it. But yeah, we want to try, replacing the guts of some products. You can get these actually at CVS, it turns out. Like, we went to CVS and we're like, oh my God, you can like buy them there for $10, and replacing the innards with an ESP32 board. And then we also, the original point of this hack chat was to show off the Bus Pirate board, which we kind of got distracted. Scott and I have a little bit of a squirrel issue where it's like, anything. So we worked on this, and then we like booked the hack chat, and then we like forgot to work on it, and so like it's been sitting here. So I've got the
yeah, I do have that too.
I've got the this board. So it's a replacement for the Bus Pirate, which was originally designed by Dangerous Prototypes and Seed. Yeah, you got one, and it used FT232 RL into a PIC 18 or 24, I don't remember. And it was, a great little like Swiss Army knife for hardware hacking. I really loved it, and we stock it. We were stocking it, and then our last time we tried to book an order, Seed was like, yeah, we can't get the chip anymore. We're not making it. So it's good. It's been at least temporarily discontinued. Which is a bummer. So we want to, we were like, oh, PIO would make this like really great. You can do so much stuff using almost any pin with PIO. And so, do you want to talk a little bit about the development? I know you were also doing some workflow with not Sele, but the
SIGROC.
Logic, SIGROC.
Yeah, I definitely went down a tooling rabbit hole, which I'm kind of down still. But I had never really used the Bus Pirate, so that was kind of new to me. But you had the idea of re-implementing it on top of CircuitPython, which I've gotten pretty far, but it wasn't clear to me like which parts of the Bus Pirate people really use. So we're still asking people, like, if you use Bus Pirate, let us know what pieces you use. And there's an open repo that I can link to in the chat for the Pirate code as well. So I did that, and then the other thing I was poking at is SIGROC is the open source, open logic analyzer stuff, and there's a logic probe software or firmware for the RP2040 that you can use to capture, and there's a pending PR, but the SIGROC project itself is not that available. Or not that active, so I'm re-implemented the core of SIGROC in Python, so that it makes it much easier to extend without having to be blocked on some like central repository. So I was doing that too, and then I've also been playing around with like Orb Trace and Blackmagic Pro too. So tooling, lots of tooling stuff.
Yeah, and one of the funny things is, the cool thing about the PIC that was the original Bus Pirate chip was that it was 5-volt compliant. Like literally, it was like in the data sheet, it was like you can use 5-volt signals even though it's a 3-volt microcontroller. And I know there was a Bus Pirate V4, and I think that was also using a chip that had some 5-volt friendly pins. But the RP2040, I was like, nothing in the data sheet implied that you can have 5-volt signals. And so I was kind of the toughest part of the hardware design was dorking around and just figuring out like how do you do level shifting for 5-volt so you can use 1.8 volt, 3.3 volt, or 5 volt logic with bidirectional pins for I2C, SPI, SDIO, and then you did SWD, which I thought was cool because the original Bus Pirate, I don't think they had SWD support. So having that all work on different logic levels. And we found a comment on it, a thread from like a Hackaday that's where Evan from Raspberry Pi says, "Oh, actually, it is 5 volt compliant. It's just we don't talk about it." So we do have a little bit of protection circuitry now, but we've removed the Zener diodes. So we'll have to do another board spin, but I think the hardware is good. We just we got to finish this project, Scott. I got to finish this project.
Well, I mean, we had talked about the plan was to like get the original or the first batch of hardware out so people could try it and then give us feedback on this.
I know. I just gotta I have to get over that fear of like, what if like there's something wrong? It's like I just have to like release it and be like, okay, we're releasing it.
Well, yeah, we could fix it.
Okay, somebody asks, what audio codec does the My Little Hacker use? That uses the Max 98 357, which is a 3 watt. Thanks, Phil. A 3 watt audio amplifier that has I2S input, and it's like really inexpensive. It's only like $1.25 or so, and so it makes for a great because we use the speaker that's in the original toy.
Right. So CircuitPython only supports wave playback on the ESP, though, I believe, too.
Yeah, because the MP3 decoding library, with the one we're using is, I believe, the Real Player one, which is optimized for ARM Cortex. And so, that's what we use. And it does really great on ARM Cortex. You can even decode MP3s on the RP2040, despite it being a Cortex M0. I mean, it's an M0 Plus, but it's still an M0. It doesn't have DSP. It doesn't even have floating point. And yet you can decode, like, not the 32 kilohertz mono, but you can decode MP3s on it. The ESP32 S3 can S2 and S3 can do wave, but it can do wave very well, and you can do audio mixing even with wave. Because despite it not having floating point, despite it not being ARM Cortex, the ESP32 S2 and S3 are fast and powerful enough to do the.
Can you type some of this in the chat for the audio codec for what My Little Hacker uses?
Oh yeah.
Yeah. And then John had a question in YouTube about forking for MicroPython that we could talk a little bit about too.
Yeah, I started to. I'm just like, here we go.
Let me finish typing. Hold on. Wait, I have like 5,000 Windows codec is max.
I know.
57.
The folks are chatting on the Adafruit Discord server too.
About
it. I can answer John just in the video. What was the rationale behind forking MicroPython into CircuitPython? This is something we did back in 2016-17. So I started working on MicroPython in the fall of 2016. And it was like early 2017 where we decided that we were going to rename and continue kind of our fork. And the reason that we renamed is we wanted to be really clear the differences between the two. Like we had already forked, we added SAMD support. But then one of the major things that we didn't see eye to eye with Damien at the time was how we would structure the hardware APIs so that they were uniform across all the ports. If you know CircuitPython, we have bus I/O and digital I/O and things like that. And the technical side of that is that those interfaces are factored out so that they're not port specific. And that's not something that Damien wanted to do at the time. So that was one of the major technical challenges that we wanted to do.
I also had I had a strong, and I have a 1-hour talk where I talk about this, but I had a really strong philosophical decision to make, which was I did not want to have libraries that were both CPython and MicroPython, because I'm the one who was like writing and supporting all the libraries, and we had like hundreds of libraries, and I was already porting all the libraries from Arduino for all the sensors and devices and chips and everything from Arduino to Python. And I had a bunch of Python libraries that would run it on like a Raspberry Pi or a BeagleBone. And then MicroPython came along. MicroPython had a totally separate way of doing hardware APIs, and also like the low level libraries like OS and Time were also different. Like there was some overlap between MicroPython and CPython, but not that much. Like it was very easy to write code that would not run on one or the other. Whereas with CircuitPython, it's like, look, I'm not going to port every library all over again to MicroPython. It needs to be a strict subset of CPython. And this was another thing that we did not agree. Like MicroPython team said, no, MicroPython should be allowed to kind of do whatever it wants with the libraries. If we want to stick new things into time or OS
Right.
or whatever, that's our prerogative because it saves space and it makes it faster. And I was like, well, I care more about my time managing these libraries and keeping them maintainable than like saving a couple bytes here and there. And so another decision that I was like very strict on was whatever code we write for CircuitPython has to run on CPython with no weird, freaky, like inline changes to try to like massage it. Obviously, some things like NumPy don't exist on CircuitPython. There's some things that don't fit on the smaller chips, but everything that runs on the smaller chips should run on big Python.
Right.
And that was also, it was just ironic they just changed their minds. But until last week, they disagreed with me on this. And so it was a big enough change that it was like, well, we can't call it MicroPython anymore because it would be unfair to people to think that they could run MicroPython code or CircuitPython code on the other because of they would fail on import. So that was like one of the biggest things is for me to be able to maintain the libraries and the code, it has to run on Raspberry Pi or BeagleBone or desktop. A lot of our examples actually run on a desktop computer or on these little microcontrollers. So that was a low-level change.
One thing I'm going to add is just kudos to each team, MicroPython, CircuitPython. So each team, we talk with each other. We try to help, how do we make the best possible open source thing. Both efforts are open source. But every single year, Adafruit contributes financially to MicroPython. And we also have helped the fundraise that has kept them going, which is the GitHub sponsor. So if you haven't, go to GitHub, look at MicroPython, sponsor it, because I did a article GitHub thing where I'm just like, here's all the forks of MicroPython. There's a ton. So someone
like the Microbit forked MicroPython and their code is completely incompatible, and the Laboris ESP fork is also like totally different at this point from the mainline MicroPython. So it's not that unusual that there's a lot of forks. It's just we actually renamed the fork.
The story that hasn't been told, it's very confusing because you can have 50 different MicroPythons and none of them are compatible. But CircuitPython, what it is, and MicroPython from Damien's team, what it is. But if you're interested in supporting open source, the reason why a lot of people are able to build off of MicroPython, it's because it's open source, and we're starting to see not as many things be open source. So this is a chance for folks to support the things they want to see in the world. We were the biggest supplier of the MicroPython boards when Damien was making hardware. That was a way we like to support efforts. But all these things work together. And this is a really good success story because not every flavor of MicroPython is going to be maintained or make sense. There's the Lego version. They're not going to do the same things that CircuitPython's doing. They're not going to do the same thing that MicroPython's doing.
And to Scott's credit, somebody asked like, why didn't you put that effort into MicroPython? We really did offer, and I said, Scott, I will pay you to work on MicroPython. That was originally what Scott was hired to do. I was like, I'm going to pay you to work full time on MicroPython, and MicroPython said they didn't want.
I mean, and I think it's fair. We should also acknowledge just how much work it is to support somebody contributing on your repo, right? So like, by having CircuitPython be a separate repo, it meant that they didn't have to do a bunch of code reviews from me at the time. And then we have more people that were doing that too. So it's not that easy. It's not that easy to just stay as one unit.
Yeah, I mean, like there's no like frustration or friction. It's just like we all said, hey, wow, like the things we want are slightly different. Let's just do our own way. But here's the thing, it's all Python on hardware, and like the code is, the stuff you learn from CircuitPython or MicroPython, it's really easy to port between the two. I think Alistair from Raspberry Pi even just posted up a project where he's like, oh, I took a CircuitPython version of the code that Liz wrote and I just like tweak and mod it and I made it work on MicroPython on the PicoW. And I'm like, that's cool. Like, and like I do that all the time. I take code that's written for, that's MIT licensed, that's written for one microcontroller and you port it to another. The timers are different. The ADC is different. You have to put some if-defs here and there. It's not unusual. Like even if something is written in C doesn't mean it's necessarily going to even compile using a different, a different compiler, like moving from Arduino to MCU Expresso to, whatever TI's thing is called. You're going to have changes, even though it's the same language. Atmel Start is nothing like what NXP has, which is going to be nothing like what TI has, just nothing like what Atmel used to have. But I think it's like, part of this ecosystem. I think it's what's nice is that people do have choices and they can have the same kind of interpreted language experience, but different hardware is going to have maybe different versions of MicroPython. Like if you're on the microbit versus the Pi board versus Circuit Playground Express versus for us running the API on Raspberry Pi.
Yeah. So
got some more questions in the chat if you want to check it out about the C3 and.
Yeah, I was gonna do this one from YouTube first, the Tyeth one, because it's in this vein. So Tyeth asks, does this mean that there could be a reconvergence in the future? And this is something that we like revisit from time to time, both with us CircuitPython folks and when we talk with the MicroPython team, which we do maybe once or twice a year. And every time it comes up, we still have some things that we want to do differently, like between the MicroPython team and the CircuitPython team. So it is something that we do talk about, but we haven't figured out how to actually like agree on some of those things. The hardware APIs is one of them, and then workflows is the other. So they're very MP remote focused, which is which is a command line that you would run on your host computer to transport your files to a MicroPython device and back. But that has not been our workflow focus, and we have a lot of workflows now that we try to keep somewhat uniform across all of the ports. So I don't know what they think about moving all of that. So David says, is MicroPython upstream of CircuitPython? Yes. And Dan is active. Dan is another engineer on CircuitPython. He's actively working on updating us to a newer version of MicroPython. So we do occasionally, we will update again from time to time.
I think Lauren and I were walking to the office and we were talking about changes with MicroPython and changes with CircuitPython and just like computer science in general, which is a form of science. Eventually, some of the same things get discovered or uncovered. I always like to think of like a civilization went away. What would be the things that we all discovered again? And I think there's things that MicroPython's doing now. There's things that CircuitPython had to decide a long time ago. Like we had the little micro thing, the way we were naming stuff. It was something to say this is something that's only for microcontrollers, and I think MicroPython is trying to move away from that now. So I think there's decisions that eventually, when you have to support different boards, like MicroPython wasn't supporting as many boards as us when they first got started too. I think there's a natural convergence, and that's why we can contribute and do stuff. But I don't know what's going to happen in the future. Good question.
All right, somebody asked if we can support boards that we don't make. Tons. In fact, a vast majority of the boards that are in CircuitPython are not made by Adafruit. Anybody can submit a board. We have a tutorial, which somebody pasted in the chat, on how to do that. You do need to have a unique VID, PID. That's a requirement so we can identify boards in the future so you cannot gank other people's. But we have open PID codes that Scott helps maintain that can get people PID codes for open source hardware, but also Espressif and Microchip and Raspberry Pi all have a VID that they can parcel out PIDs. You just have to ask them. So yeah, we have a lot of boards. One of the things that I think is really neat is that we really let anyone submit their board and we accept it. You just have to do the bare minimum, which is get a photo to us and do the pull request and make sure it passes the pylons and all that good stuff. But that just means that we can support it going forward, and we translate it into 12 different languages,
something like that.
Yeah, it's cool.
So Steven's questions, if I roll my own C3 or S3 board, can I load CircuitPython? Yes, definitely. And Tashipu, thank you for linking to the guide. How much memory? Basically, if it's an ESP, you have enough. The minimum that we have is that SAMD21 with 32K RAM, and it's tight.
Yeah, it's
We
tight.
wouldn't.
I'll say the S2s without PSRAM, it's a little tough to do Wi-Fi things because the moment you start doing Wi-Fi, you're like, a lot of your memory is being used for TLS and buffers. So if you're using an ESP32 S2, get PSRAM. But the ESP32 and C3, they all will boot and run code.
Yep. So the second question is, does CircuitPython support Bluetooth on the ESP32? So on classic ESP32 with Bluetooth Classic, we do not support it. We don't support BLE on the S's as well, or the C3, I think, has it too. We'd like to, but the problem is that it uses a different stack than the stack that we've used for BLE previously. So our BLE support really is on the NRF 52840. And then 3, does CircuitPython support over-the-air updates? We have the web workflow, which is a network, like an HTTP server that the device will present. And you could also do the phone home yourself from CircuitPython code, but we don't have a native like call out OTA sort of mechanic within the core of CircuitPython. So you'd have to roll your own. It's not built in.
Okay, and someone in YouTube asks, Arduino now has great support for MicroPython. Are we working with them to support CircuitPython? I think it's great. I think it's good that they're offering MicroPython support for their new ESP32 boards. I think we have a PR for adding support for that board into CircuitPython, but it was hanging. I think like Melissa was poking at it, but I think she figured out what it was. I think the SPI RAM was not set up to be octal or something. So we'll probably have support merged in this week or so. And one of the things about the way CircuitPython is structured, which like again, kudos to Scott for thinking about this so far in advance, is that it's really easy to add new boards with all the pin names, and it just kind of magically works. Like as long as you're using a chipset that we support, there's other than little like minor details, if they're doing something a little unusual, new hardware comes in and it kind of just works magically, and the board definitions mean that you get all the pin names. The unavailable pins aren't in the board definition, and so like you don't have any mix up, and if they have naming, the naming comes through, and if they have a default I2C port, we say, hey, this is the default I2C. So, and if there's built-in hardware like a display, the REPL shows up on the display. So there's a lot of stuff you get. There's a big kitchen sink that comes in when new boards are defined. So I think probably by the end of this week we'll have that new Nano supported.
One thing worth mentioning, since it's like CircuitPython happenings and it's been a year since we've done a hack chat, is when Scott joined, Scott was working on his own hardware company, and we've always worked with makers who have hardware companies. And it wasn't like a specific conversation, but it's just how, when you do open source, there's a lot of benefits that you don't really realize until you see it out there. So there's people who run businesses that sell boards that every single time there's a CircuitPython update, they get all those features added in because it just works. Because they've made their board so drop a new UF2 on there and you get all the features. I think one of the best examples is the person who does like a little minifig looking board. Every single time they do a new revision or a new board or pick a different chipset or whatever, it just works. So if you're someone who's looking to not really focus on unending firmware forever with different chipsets, you can focus on just your hardware design, and it's enabling a lot of makers to run complete businesses without having to remake and maintain the firmware. That was another thing. When we were adding the CircuitPython.org pages, it was like it used to be so hard to find the right firmware for your board, and now I think we've solved that.
We really made it. You get the absolute latest. We now have artifacts on every PR. It's good stuff.
And it's weird because, like I said, I mentioned it earlier. I just finished up this article about open source, and when people start out in open source, it's like, yay, fun, this is great and sharing. But then when money gets involved, like commercial use, oh, I don't really like that. We went the opposite from the very beginning. You're able to make your own hardware and use all of this stuff, and that's probably one of the best things about open source. You don't have to worry about getting permission, signing NDAs. You can always fork it if something changes, and customize something for yourself. So I think it's
MicroPython's MIT license, and so are we. And I think it's great.
So I think since the last time we did a hack chat, there's probably maybe 100 boards that were added. altogether, ish.
Sorry, what would we do?
100 boards that were added in CircuitPython.org.
Oh, easily.
Yeah. So, and that's like
about 1 week.
Yeah. So I think that's kind of cool.
And a lot of boards were also added with Blinka support. So you could run all those libraries, all those sensors libraries. All of them will work on your Orange Pi and your Onion Omega and your Banana Nano, whatever. That'd be a cool name, Banana Nano.
I think that's really shown how good our API has been designed, is that it did port really easily to into CPython Linux land.
And we got another thing I love about CircuitPython is all the board definitions are included in the repository. They get tested on every change. If something breaks on your board, you know immediately. Yeah, like where the tooling is intense. But
thank you, Microsoft, for paying our CI bill.
I know GitHub, I'm sure, is just like, how much? I mean, it's a lot of work because we build every PR. We build every board and every translation to make sure everything fits and everything compiles. And once in a while, like people have a new thing that they've added, a new cool peripheral or module, and it's like we verify that it tests and builds on every platform. But it saved us so much time. And there's definitely been times when I'm like, oh, I want to add a new board definition instead of setting up the tooling on my computer. I'll just do the PR and then like have dinner, come back, and then it's ready. The artifact's ready for me to test. I'm like, yay, thank you, Cloud Compile.
So I think during the Raspberry Pi shortage, when people were using other single board computers, Blinka was handy.
Yeah, totally.
Oh, definitely.
I mean, I think that's one of the perks of using MicroPython or CircuitPython in general, is that the code you write on top of it is a lot more portable.
Yeah, I mean, you couldn't get Pis, and people were like, okay, I still need, I have this Orange Pi or this Banana Pi thing, and like they were still able to run the things, hook up sensors, and not get stuck. Looks like you got some more questions in the chat.
Yeah, this is a good one. So Aria asks, if I control C from like code.py or main.py, I get a REPL and all of my state's been preserved.
Yeah, MicroPython has state preservation. We decided to do a clean slate. That was a design choice that Scott made early on.
It is a design choice, and the reason I did it is because I wanted you to start from a clean slate. Like I want to minimize the amount of state that goes over between runs, so that you're always starting from the same place. And that was true with the REPL as well. My answer to I think the way that I debug is by print debugging, and so it's not that as big of an issue for me wanting to access state kind of in the REPL after codes run. There has been some discussion of like debugger support, which I think would be a better option, because then you could resume. Like the problem with like bringing all your state into the REPL is that you can't resume back into your code that way.
I think that the trade-off is that we have very fast when you save, it reruns. And so like I'll often, if I'm working on code, I'll go in and add prints or whatever, or like JSON debugging, and then I'll just like save it, and it reruns instantly. So like the 2-second rerunning is the trade-off, because if you think about it, like again, CPython doesn't act that way.
I wish it did, because I'm like, oh, I gotta go over
and if it did, I think we would make it work that way. But it's like we kind of went back to a lot of things. Were like, what is this thing that we're doing? If CPython doesn't have that behavior, like and like people are always like, why don't you have like interrupts and threads? And it's like, that does not exist in CPython, and it doesn't. We're not going to add stuff that
Python-I
is extremely hard to use, and CPython doesn't support. Like that's two knocks against it.
Yeah, I think we might be talking about slightly different things. Python.I, I don't know what Python.I does, but we should be explicit, because we didn't talk about this when we were doing MicroPython versus CircuitPython. But one of the early things we did with CircuitPython is whenever USB writes to the file system, we'll auto stop your code running and rerun it again. and that's something that that MicroPython has never done. And
would it be possible to
forward to
repatch the MicroPython like Command C state, or is it like it's so ingrained like the state clearing? Because we like tri-state pins and.
I mean, we could make it work that way. Like there's just a reset call in CircuitPython that we would not do, but
Arya, you could patch
I
it.
wouldn't do it. Yeah, if you want
If you want, you can add a
we could do
compile
it.
time. You could add a compile time thing, and we would merge it. It wouldn't be on by default, but like you could add it. We just have a reset function that resets everything.
I think
for
you may find issues. You'll have to be delicate to make sure it's only when you're going into the REPL, because another thing that we do is we keep track of in-use state much more strictly than MicroPython does, because we don't want you to accidentally use something twice. And one thing that the reset between runs does for you is it actually resets all of like the notion of what's in use.
Yeah, does MicroPython do resource locking? I think they don't, right?
Last I looked in detail, it wasn't the case. It was like something that you had to make sure and manage.
Yeah, we do resource locking, but that is what's cool about that is you can have an OLED display that has your REPL on it and is like printing out your debug state, and you're using I2C in your program, and you don't have collisions, right? Like when I2C is being used by the CircuitPython core to display on the OLED, it halts, waits, and then it releases the lock. That was also a really, really big project to have everything. And you did that very early. You resource locked all the
when we're
GPIO,
like
I2C, SPI.
yeah, those buses where you would like be using them between multiple things. It is particularly handy for sharing with the core, which does happen in the terms of the display stuff.
You're like, you're playing audio and you're reading from the SD card, but you can still access the SD card, like to read other files. It's just like, extremely hard to do, right? You have something that's streaming audio out of a WAV file, but at the same time, you can access the SD card and it acts like a normal file system, like it would on a computer, or like on CPython. But yeah, that requires a lot of work, and that's part of the reset state management. It's it takes a lot of work to make things look so easy. And this is a good stuff for like when you do the deep dives, people should come by because you get
this
into
is
this
totally
stuff.
the sort of discussion we talk about.
And like USB host is exactly the same way. Like, how do you natively support USB host when you plug in a keyboard?
Yeah.
The REPL is like, no, the key's coming into the REPL. It's coming into the main interface. It's not just a peripheral.
We also worked with some educators. New York City has one of the biggest school systems, and they had this like magical vision of like, what would be great is a $20 microcontroller that plugs into a computer that just shows up as a USB drive, that you just save Python to it and just runs every single time, and you don't need any IDE to download, and you don't even need an internet connection. Like it starts to like, okay, and Circuit Playground Express with CircuitPython does that. It's possible to use a text file, edit a main.py, and you can be doing stuff. Now, of course, you want to use IDEs, and there's classes that have more structure than just like a USB drive. But like that's one of the things that constrained environments like schools, and they don't have the best computers either. They can't download everything off the internet. They just essentially wanted to edit a text file.
Actually, one of the things that drove me really not nuts, but I was doing workshops and people would upload code and they would be like, I don't know what's running, because I uploaded the binary to this microcontroller, and they're like, and you're like, well, what's running on that? And they're like, I don't know if it's just what's on my editor. Like it's because it's this compressed state. What's nice about embedded interpreted languages, it's like whatever the code is, the file is the code that's running, and it's like that makes a lot more sense for people, especially when they're beginners. They don't get the confused of like what's running, what am I, where did I save it, what's going on. So for students, I think CircuitPython, MicroPython, whatever, TypeScript, all of it, or device script, all of it is a big improvement.
But the convergence that's happening is the expectation that people are having that things show up as a USB drive to drag and drop firmware off. Like that's happening. I think even the latest Arduino that just came out uses TinyUSB. That's one of the Adafruit sponsored open source projects out there. So
Yeah.
it's kind of going back to like with the earlier questions, like where do you see things, coming together? There's a lot of things that the users eventually need and want, and I think that's where you're going to see, oh, like these are more connected here. Anyways.
And TinyUSB is a good example where we're seeing MicroPython adopt it for new stuff as well.
And Arduino, the latest Arduino core also uses TinyUSB.
And Arduino and ESP-IDF and Pico SDK are all using TinyUSB. So even if we don't use like MicroPython stock, there is more stuff that we share with them under the hood.
Yeah, it's a fully funded Adafruit open source thing. Adafruit's name isn't even on it, I think. So
no, it's
that's
not.
okay. Well, because it was started before, it was very early, and it was started when TAC was doing other stuff. But now it's like his full-time thing.
It fuels so many things, and we get contributions from the community.
Yeah,
and
lots of contributions, which is great. It's like once you get a certain momentum, people are contributing back. So like Espresso uses it. Pretty much everybody except for actually, even the big chip companies are starting to use TinyUSB.
I think
because
so, yeah.
I was looking. Maybe it was the Renaissance, or maybe it was the CircuitPython MG25 core from Scilabs. I think they use TinyUSB.
Yeah,
they're like, oh man, we don't want to develop a USB core. That sucks.
Yeah, I mean, I think we should highlight that like it was CircuitPython that really made that switch, right? Like we had done USB stack stuff with Atmel, and I think it was CircuitPython 3 is when I was like, no, I gotta switch to TinyUSB, right? Like TAC had done it, but it really wasn't being used anywhere. And then, I was really wanting a cross-platform USB stack that we could use on all of our devices. And so you paid for me to spend the time to move us over. And that really, I think, gave TinyUSB the time and use to really get it polished up and working really well.
I think companies, it's funny, it's like, well, what can companies use? Open source stuff. Like this is the thing we put under a license that companies can use.
I know every other USB stack has
talk to us about it. They can just
every other USB stack has the shittiest license. It's like you can only use it if you're like best friends with ST and you buy us a drink and like you are only using a chip. It's like it's so. Right. And it's like everyone's redoing the same work over and over and over again. And I really like that.
To sign a contract or an NDA or buy 1 million chips or something.
Oh, and you found a bug and it's going to take 6 months to get it.
Yeah, we'll never fix it. And then, every time, like every new, because you were working on USB MIDI, and like USB MIDI is kind of like nuts, which I never realized. I thought it was like simpler, but it's actually weirdly complicated. And like adding that to TinyUSB means it's available now on every single port. So like mass storage works on everything. USB MIDI works on everything. HID and now USB host is also going to work. Hub support, we have USB hub support, so you can like connect multiple devices and enumerate them. And you can use them from whatever. So it's interesting. TinyUSB is really like it's like the shoulder that we stand on. Stand on the shoulders of giants. But yeah, that was a huge amount of work that that really I think opened up a lot of ports.
Yeah,
that's the toughest thing. That's the toughest part. Like all the other peripherals are hard, but USB is just a nightmare to.
You got to get the workflow first. Ugh. You got to edit your CircuitPython code.
That's right.
So I do see one question that I missed in the YouTube chat, which is from Chris Lopez. Says, how painful would it be to use something like a micro SD card as the disk? I know I can mount it as the file system, but that's not what CircuitPython will mount over USB.
We did actually try to add the SD card as a secondary LUN, and there was some weird operating system bug that TAC got stuck on, and then he's like, I don't want to work on this right now. I think it was Mac, but it could be fixed. Maybe it was a bug in like Mac OS. We could go back and look at it, but we were getting close to being able to mount it.
Right.
I'll say, by the way, mass storage, it's amazing, but it's not really designed for what mass storage became. It was designed for SCSI drives that would never get unplugged. And you only had one thing connected to it. And what's weird about the way CircuitPython works is, of course, you can have the MicroPython device right into the disk and also the operating system that you're connecting over USB. And like SCSI just is not designed for this whatsoever. And that's why when you plug in like your phone or your Kindle, it comes up as like this weird, like not mass storage drive. It's called like the gadget USB drive, because there's just no, it's just like the operating system can't deal with the fact that the the files might be changing due to some other microcontroller writing to it. It's like totally freaky.
Yeah. Deshipu points out MTP, but that's not well supported on Mac last I looked either.
Yeah, we've looked into it.
So,
It's we did. I think we got really close to the secondary LUN, but I think there was something that I think again that the operating system was it did not like it if you were mounting it read only and you were changing files on it. Like it freaked out the operating system, and I think it even like caused some crashes, and we couldn't quite because it's just such a bizarre thing to do.
I had to restart my computer yesterday because I was doing some weird stuff with USB. Like my actual Linux computer. You can mess up USB enough that you got to restart.
Oh, I've had USB so messed up that I had to like not only restart, but I had to like shut down my computer, unplug everything, depower my hub, wait, because like something was like it was messed up and it was back powering.
Oh no!
I have a good hub too, but it's I don't know, something like
power
leaks through and like keeps something on.
Yeah. So
USB,
for the
USB development is fun.
Yeah, so the micro SD card as a disk through USB is something that's on our radar, but we've hit some hurdles. I think there is a pending PR for it, and there's probably an issue as well that you could follow for when we actually do get it working. I think it's possible to get working. We just haven't done it yet. And I think Lamore, you wanted similar for the web workflow as well. The other challenge on the CircuitPython side is that SD cards and USB mass storage devices, which is what I've been playing around with, those will be from Python code itself. And that makes it really tricky because the moment that you have the workflow calling into that drive, you're actually running Python in like intermingled, like multi-threaded. So that gets really tricky. And I'm not sure how we want to handle that. So it's on our radar, but not something that's coming immediately. And then
I found the LUN. So yeah, TAC did the multiple LUN request, but yeah, it was you can look at it again. You never know. Like sometimes like things like magically start working. But I think we might have to change what our expectations for like how the operating system what we're willing to expose to the operating system. But yeah, basically like computers were just not meant for what we're trying to do here. Which is another reason, like, when you have CircuitPython plugged into your computer, you can't data log to the internal storage while you're also writing from the computer. Because the computers cache so much of mass storage, and they also write non-linearly. Again, it's just like what we're doing to this poor SCSI protocol from like the 80s is hilarious. But yeah. Okay, cool.
One last question I see is any chance for Zigbee support on things like NRF 52840? I think it's safe to say that Adafruit funded folks probably won't spend that time. But if somebody wanted to add it, we're happy to guide you and
I think somebody added ESP now, so it's like people do add other protocols, but we just haven't gotten to. We don't have the. We're busy working on this microSD LUN problem, right? No, I don't know.
Well, I'm doing USB host.
USB host, but
I'm in that world.
Yeah. Okay. All right, we want to wrap it up. We've been here for an hour.
If folks have more questions, you can go to the Discord server, adafru.it/discord/Discord, and then the CircuitPython dev channel is where we all hang out and work on CircuitPython. So if you want to do custom builds and stuff, that's the place to go. We also have a help with CircuitPython channel where you can get help just using it as well.
And other things, we met Scott because we do a show every Sunday called Desk of Lady Ada. So come on by. Lamore shows all the electronics she does. She has pink hair. I don't know, some of you have heard that. And she does all of her electronics. She says,
I do electronics. I indoctrinate you into like the woke philosophy. It's all there.
And
come on by.
Yeah, and we show what's on Lamore's desk. And then we do a great search, which is how to find stuff on DigiKey, on Ask an Engineer, which is turns out later today. We have INMPI, which is usually a new chip or a new thing that Lamore thinks is really interesting, and all of the new stuff we have going on. We have our CircuitPython segment, which is our Python on Hardware newsletter, which is like our collection of everything that's going on in the world in Python on Hardware. It's kind of the best time to, I think, do microcontroller stuff. It sucked for a long time, and now it's a lot better. So
better.
check that out just to look for the project collection. I think that's a big chunk of the newsletter that folks really like, but also events and things.
And don't forget to donate to the MicroPython on GitHub.
I put links in the chat.
Yeah, because they don't sell hardware that much anymore. And so I think that they really can do much more work, and they've hired people to add more capabilities to MicroPython thanks to the contributions from everybody.
Yeah, and they do a great job of saying something has been funded by GitHub sponsors.
Yeah.
I think that's really nice that they do that.
Yeah, and like for everyone out there, because if you read Hackaday, there's a lot of things going on in microcontrollers. If you like to see things like MicroPython and CircuitPython, support the companies the way you can. Buying boards is okay. Participating in the community is really good. But open source communities, make sure that we're also amplifying the contributors and being cool to one another. It gets really hard sometimes, I think, when you get demands or folks that aren't being so nice. We have like code of conduct and everything, and this community is good, but it's one of the things that's really hard, I think. It literally forks communities. So a little thank you in a GitHub issue, or in a chat or something, like these are all really good. Or it goes a really long way. There's a lot of people working on Python on hardware right now. So thanks to Hackaday for having us. Very much appreciated.
Mm-hmm. And join me for my deep dive at 2 on Friday.
Back.
Yep, I'm streaming on Sundays. Scott streams maybe on Fridays. Lots of streaming. And of course, you can always come by and ask us questions about, you want to do stuff with CircuitPython. Discord's a great place to go.
All right.
All right, bye, everybody.
Video. Bye-bye.